Greetings to you all and good evening. Welcome to MS 211 Group 1 presentation from Tonga. The topic of our presentation is size, abundance and composition of sediment. To begin with, we try to define sediment. Sediment is a natural occurring substance composed of small particles which were broken down by different natural forces, and it can transport by wave and wind. And our questions arise why it is important to study sediment. This is because sediment size is a good indicator for the amount of wave energy in a beach. And also, sediment is the main composition of every beach. The objectives of a field trip is to identify the average size and abundance by analyzing the composition of sediment in Hatafu Beach. Hatafu Beach is located on the western side of Tonga Tapu, as shown by the map identified by this red ring. Thank you.
We continue on to the material and the method we are going to use during this field trip research. And in this field trip research, we are dividing our material and the methods into two parts. The first part is sample collection, how we collecting of our sample. These are the materials we are going to use: a 20-meter tape, plastic bags, and a sellotape for labeling our sample. The method we are going to use in this sample collection: first, we stretch the 20-meter tape perpendicular to the beach, starting from the top to the bottom of the beach. Second, from every 4th meter in the 20-meter tape, we collect the samples, starting from the 0 mark of the meter tape up to the 20-meter mark. Then we label each sample respectively. Second part of our material and method we use in this field trip research is analyzing of our sample in the laboratory. And these are the materials we are going to use in the laboratory to analyze our sample: receiving can, light microscope, spatula, top and balance, petri dish, and a sediment ID book. The methods we're going to use to analyze our sample. First step, for the first sample, we put the sample in the receiving can and shake it well for 6 minutes. After shaking the sample, we collect every different size of the sediment from the receiving can and measure it under the top and balance and record it. From that sample weighting, we are about to use part of that sample to view under the light microscope and to analyze and to identify the sediment type and to count it. And for the rest of the sample, this 3 steps, we are going to repeat it one by one of the samples to analyze it. Thank you.
Thank you. I will move on to our result. This bar graph here tells us the abundance and composition of sediment that we have found in our sample. As you can see, each bar here with different colors indicates different sediment type. As you can see, the violet colors dominate all samples. This violet color represents that coral fragments dominate the the samples, followed by the mollusk and other sediment types. This frequency curve of weight in percentage can tell us which sediment size was the dominant in our sample. As you can see, that all weight in every sample are higher than other weights of the samples. As you can see, it's the 0.5 millimeter sample dominate our sample. The fork and rod statistic. As you can see, the mean size for all sample are almost the same. The sorting values are below 0.5 and the skewness are all negatives. Now move on to the discussion. The most dominant size of sediment was the 0.5 millimeter. Because of its size and its mass, it is easily transported along the beach by the longshore drift. And this beach is exposed to low wave energy because of its location. As you can see, this beach is located on the western side, but the trade wind is from the southeast. So this beach is sheltered from the trade winds, and we expect this beach to have low wave energy. And the most abundant sediment type was coral. According to Mr. Bruckner research, he stated that around 1,500 square kilometers of coral reefs are found in Tonga. So we expect every beach here in Tonga to be dominated by coral sediment. These are the composition of the sediments that were found in our samples. As mentioned, we are dominated by the coral, followed by the mollusk, rock fragments, forum, black grain, other organism, spiker and sponge. Our finding of the black grains is an evidence that this beach is facing the ring of fire. And we experience in the lab that this black grain is very smooth and small in size. This shows that the sediment has been transported over a long distance. And we found rock fragment. This rock fragment is the result from the cliffs that has been recently eroded many years ago. As mentioned before, all samples was negative skewness, as all values were negative. Our sorting value was ranged from 0.35 to 0.5. This indicates that the sediments are well sorted. In comparison to other groups' results, we agree that the dominant sediment type was the coral, and the most dominant size was the 0.5 millimeter sediment. Thank you.
Thank you. We move on to our conclusion of our presentation today. And you can see, we'd like to stress some few points on the slides. The first one is the average size of sediment in this beach is 0.5 millimeter. The most abundant sediment type is coral. And the sorting, as we have shown in our table, range from 0.35 to 0.5, which shows that the sediment in this area is well sorted. Lastly, the size of sediment can tell us about the amount of wave energy that this beach exposed to. The sediment abundance and the composition depends on the dominant sediment source in the area. Thank you. Now we move on to our question session. Is there any question?
Thank you, Nimilati. I have two questions to ask. The first one is, how do you know that Hatafu beach exposed to low energy? And my second question, what do you mean the beach of Hatafu is well sorted?
Thank you for the question. I'll try to answer the first question, and then I'll leave the second question to one of my group members to answer that question. But the first question is asking about why do we say and why our group believe that this beach exposed to low energy wave. We have some few points here, as we have stressed out in our presentation, that support our stance here. The first one is the size of the sediment. As we have mentioned, that the most dominant size of sediment in this area is the 0.5 millimeter size sediment. As we can see, this type of sediment can easily transport around by the longshore drift, as we have mentioned, but due to the low energy of the wave, they deposit down in this beach. And they are accumulating as this beach is exposed to low energy wave. The second one is the location. As we have mentioned in the presentation, that this beach located on the western side of Tonga Tapu. And the trade wind of Tonga come from the southeast, so this beach is sheltered from wind, especially the strong wind. This beach has a very less wind. The next one is the slope of the beach profile. We all see that this beach here, the slope of the beach was less steeper. As we all know from the notes, that the more the steepness of the slope, the more energy of wave that are exposed to that beach. But this beach, like Hatafu, they exposed to a very low energy beach because the steepness of the slope was very low. I think I answered your question, and I'll leave the second one to William. Thank you.
Thank you. Now I'll answer the next question. Well sorted is an indicator for sediment size. Well sorted, by saying well sorted, it means that the sediments in this beach have similar sizes, but not mixed up with different sizes. But as we evidenced stated by Fork, he stated that well sorted sediment takes time to deposit it, but poor sorted sediment deposited rapidly. For example, like the mud flow. Thank you.